Hey everyone, in this video we're going to talk about the first derivative test for local extrema. And basically what that means is that we're going to talk about how the first derivative can help us find absolute minimums and absolute maximums, as well as local minimums and local maximums. And we can talk about how the first derivative helps us really find what these are all called is critical points. So a critical point can occur anytime that the derivative of a function is either equal to 0 or that the derivative of the function is undefined. So what we have here in these examples are we have an absolute minimum all the way down here, and at that point, A, we should know that the derivative would be undefined because there's no two-sided limit right there. Same thing right over here. On the other side, where our local minimum is that we would not be able to have a derivative at that point because there's no two-sided limit there. We can only take a one-sided derivative in both cases. At our local maximum at this point right here and our local minimum at this point right here, both of those we have f prime equals 0. We have a horizontal tangent, so those would be critical points, and we could test the left side or the right side to see whether it was a local maximum or a local minimum. At our absolute maximum over here at C4, this would be where f prime is undefined because the graph makes a little bit of a cusp right there, so it basically changes abruptly, and it would not be differentiable there because our derivative is undefined. Again, that would be another critical point. And then that brings us to the last two right here at C1 and all the way over here at C5, where we do have f prime equal to 0, so we do have horizontal tangents, but because our derivative does not change sign, it does not go from positive to negative or from negative to positive, that means that our function is not necessarily going to have an absolute minimum or an absolute maximum there. It's just not going to have an extrema. Okay. So let's take a closer look at some of these individual examples. In these pictures here, this shows the difference between when we have a local maximum, a local minimum, or no extrema. So in other words, this is what's occurring in the middle of the graph, not necessarily at the left end or the right end points. The first we show is the local maximum. The local maximum always occurs when we have a critical point. So this example you see here on the left, this is where we have f prime is equal to 0, so we have a horizontal tangent. And this example we see on the right is where we have f prime is undefined. So either case could give us a local maximum. Remember, we know that if f prime is 0 or if f prime is undefined, that's going to be one of our critical points. But the way we tell that it's a local maximum is that we can test points to the left and to the right of the point where it's either 0 or undefined. And if it's positive left and negative to the right, we know that we had a local maximum. Same thing here. We know these were positive slopes and these are negative slopes, so that means to the left f prime is positive and to the right f prime is negative. That tells us that it was a local maximum. Basically, our graph, if we have positive slopes, goes from an increasing, then it gets to be 0 or undefined, and then we go into a decreasing with negative slopes. Okay. In our next example over here on the top right, we have local minimums, and it's the same idea. We go from from negative slopes down to a 0, and then to positive slopes. That gives us a local minimum. So this is the case when f prime is 0, and this is what it may look like if f prime is undefined. Right? We get this point here where it's non-differentiable. But again, that doesn't mean that we don't have a local minimum. Just because we don't have a defined derivative does not mean that we don't have a local maximum or a local minimum. And in these last two, where we still show that, okay, this part A is where f prime is 0, and this part B, f prime is undefined, these would be no extremes. And that's the reason that's the case is because the derivative does not change sign. So even though the derivative may be positive, 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 gets all the way down to 0, it doesn't go negative. And so because the derivative doesn't go to the negative, then I can't say that my function switches from increasing to decreasing. So this would not be a local maximum. The same case over here where we're decreasing, 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 and then we get to this point here, and the derivative is undefined, so we know it's a critical point, but then we're still decreasing. So to the left, f prime is less than 0. To the right, f prime is less than 0, which basically means I have negative slopes and negative slopes. So again, there's no extreme there. There's no local minimum there. Okay. Next thing we can do is look at the left end and right end of the graph. Okay. And so this top one up here on the left, this is looking at the left side of the graph, the left end behavior basically. And if we can say that, okay, we have everything greater than a, all right, f prime of everything greater than a is less than 0. In other words, everything to the right of a is decreasing, which means a, or our left end, would be a local maximum. And the same thing we have over here, if everything after, or everything to the right of point A is a positive derivative, that means it's increasing over here, then A was a local minimum. And that's kind of the example that we had back in the beginning here, where, if we look at A, everything to the right of A all the way up to here is positive. So because that's all positive slopes, that means that we had an absolute minimum right down here at A. And the same thing occurred over here where we had, everything was decreasing to the left of B. Again, that was an absolute minimum. Okay. So the same thing happens on the right end as it happened on the left. If everything leading up to the right end is a negative slope, then that means that B would be a local minimum. But if everything to the left of B is a positive slope, that means that we're heading towards a local maximum. Okay. And of course, the only difference between it being a local minimum or a local maximum versus a global minimum or a global maximum just depends on what happens on the rest of the graph. If that turns out to be the highest or the lowest point in the entire graph, we would call it a global or an absolute maximum, or a global or an absolute minimum, depending on whether it was the high point or the low point. So a lot of this stuff you can kind of figure out just by looking at the graph, but if you don't have a graph to look at, maybe it's a non-calculator question, or for whatever reason you can't see the graph, what you would want to do is test the derivative at points just left of and just right of your critical points to see, okay, is it a local minimum or a local maximum? Remember, the key piece here is twofold. Number one, the critical points are where the derivative is 0 or where the derivative is undefined. The second piece is that in order for it to be an extreme, the derivative has to change sign. It either has to go from negative to positive or from positive to negative, all right, unless you're at one of your endpoints, and then you really only need that one-sided limit. Okay. I hope this helps to make sense. I will see you in the next video. Good luck.